boy, that's not working very well, is it? Well, maybe we need to... Oh no. Okay, sorry, I'm trying to figure this out, but I'm going to have to do a personal hotspot here, I think. So let's just give me a second there. Well, this either is going to work or it isn't, and then I can send the PDF. So, sorry guys, I'm just going to take up that practice test with you. So let's take a look at that, shall we? So here we are, and we are looking at practice test. So, question 1 is about Rutherford's gold foil experiment. And if you remember, the gold foil experiment is where he expected to see small deflections in these alpha particles as it shot through the atoms. So he expected only small deflections, but he saw mostly no deflections. Okay, so he expected only small deflections, that's true. He observed only small deflections, that's false. It led to the description of the nucleus, that's true. And he saw some really large deflections, that's true. So, from that we can determine that this must be the false statement. Here we're looking for false. All right, so that one there is false. Let's go to the next question. Which of the following is true about subatomic particles? The electron is the heaviest? No, it's the lightest. Neutrons orbit the nucleus? No, electrons orbit the nucleus. Protons and neutrons have the same charge? No, they have the same mass. 1 atomic mass unit. Oh, there we are. So that's the one. What is not true? So again, we're looking for a false statement. So let's look. Lithiums have 3 protons. Well, that's the atomic number. And the atomic number is the number of protons. And it will tell you the number of electrons. And then we use this number, which rounds to 7. And we know that 7 must be made of the 3 protons and however many neutrons. And the question is, what plus 3 will give you a mass of 7? And that's got to be 4. So it's got to be 4 neutrons. So let's see. Lithium atoms have 3 protons. That's true. Lithium atoms have 4 neutrons. That's true. 4 electrons? No. We know that it is 3 electrons. So that statement there is false, which means that is the answer because we are looking for the false statement. Good. All right, let's keep going. Which of the following is true? So we're looking for a true statement. A row is called a family? No. They're called the periods. Which that also tells me right here that it can't be D because the columns are called the families. The row element tells you how many valence electrons. That's true. The column tells you how many valence electrons. Oh, sorry. The row tells you how many shells. So, the column tells us that. Yeah, we count over to know how many electrons. Good. In this diagram, we have lithium giving away its electrons to oxygen, forming an ionic bond. Note, the main reason this is here is this shows you how to draw Lewis diagrams It also shows you how to form ionic bonds, giving and taking electrons. So this question's super useful. And as it happens, I've done it right, it's good. So it shows the formation of an ionic compound, that's true. Shows the formation of a covalent compound, no. That's sharing of electrons, which is not what we see here. And the formation of Li2O, no. LiO2 rather, no, this would be Li2O. None of the above is correct. Nope, the first one's correct. So A is the answer. Good. Next. Covalent compound is formed. Well, we just set it up here. We said that this is sharing. And because it's sharing, both atoms need at least 4 electrons. I.e., they need half full shells at least. This means only nonmetals can share. So let's see if that helps us. A metal and nonmetal? Nope, that's an ionic compound. 2 metals? Nope. 2 nonmetals? Yep, that's the one. Which element will make 3 bonds? Well, if we look, hydrogen has 1 electron and it needs 1 more. So that's not it. Oxygen has 1, 2, 3, 4, 5, 6. So this will make 2 bonds. Nitrogen has 1, 2, 3, 4, 5. So it's going to need to share here and share there and share there. So that's 3 bonds. So that's the correct answer. And then just to show it can't be carbon, carbon has 1, 2, 3, 4. So it's going to form 1, 2, 3, 4 bonds. So that can't be it. All right, which will lose 2 electrons. Well, calcium has 2 electrons. That makes it the right answer. Sodium has 1 electron. That's the wrong answer. Sulfur has 1, 2, 3, 4, 5, 6. So it is going to gain electrons, not lose 2 electrons if it forms an ionic compound. Nonmetals get electrons in ionic compounds. They get or share, but they don't lose. So it can't be sulfur, it can't be boron. So the correct answer has to be calcium. All right, well, this is a Lewis diagram, and it has to have 7. So sodium is just 1 electron, so it can't be that. Sulfur has 6 electrons, 2, 3, 4, 5, 6, so it can't be that. Fluorine has 7, 1, 2, 3, 4, 5, 6, 7. So that's it, just to show. Argon has a full shell, so it can't be that. So the correct answer is fluorine. Here we go. And I have done a covalent compound showing that. Just a reminder, shows how to do Lewis structures for covalent compounds. But it does it wrong because oxygen should make 2 bonds. Carbon should make 4 bonds. So this should be carbon, oxygen, oxygen. Carbon, that's only 1 bond to each oxygen, so 2 and 2. 4 bonds for carbon, 2 bonds for each oxygen. And that would leave each oxygen with 4 electrons that it doesn't share, but just has to itself. That would be the correct version. So it's wrong, but it's wrong because it's the wrong number of bonds. So it's correct? No. You can't use a line to show. No, that's not right. You do. That's right. I have all the electrons making all the atoms making the wrong number of bonds, not just oxygen. All right. If something has no charge, it's neutral. It's uncharged, neutral. All right. If something is a positively charged particle in the nucleus, that's a proton. The first holds 2 electrons. The second holds and third hold 8. These are the orbitals or the shells. So the orbitals, there we go. An atom that has a positive or a negative charge, we call that an ion. Or we could say it's gained or lost electrons. Ion, good. A negatively charged particle found orbiting the nucleus, so it's negative and it's orbiting, that's an electron, which is up here, that should be E. The center of an atom, that's the nucleus, where all the mass is held. That's true, that's where the heavy stuff is. That's down there. A particle with a mass of 1 AMU, so that's either a proton or a neutron. And since there is no charge, can't be the proton, so it's got to be the neutron. That's G. And the outermost orbit, well, we're down to just this one left, but that is indeed the valence shell. There we go. You know, all this information is actually in the previous question. Protons, they have a positive charge. Electrons, they have a negative charge. And that tells us here that the stuff in the nucleus are the heavy ones. So that's the proton and the neutron, they're in the nucleus. 1 atomic mass unit, 1 atomic mass unit. An electron rounds to 0 atomic mass unit. Really, it's like 0.002. And they are found in orbits. And this has no charge. Good. Ionic bonding and covalent. Ionic. Bunch of stuff we could say. We could say a metal and a non-metal. We could say give and take electrons. We can say held together by opposite charges. And covalent, we can say 2 nonmetals. We can say it's the sharing of electrons. And we could, of course, draw what each of these looks like. And if we look here, carbon has 4 electrons, each hydrogen has 1, and a sharing is always of a pair, 1 from each atom. So we call that a shared pair of electrons. Whereas, on the other hand, we can have here a giving and taking of electrons. So sodium empties its shell out. It's a lot easier for it to lose electrons than to gain them. And chlorine fills its shell up. Both now have charges. The chlorine's negative, the sodium's positive, and that opposite charge holds them together. Oh, we need the periodic table here. All right, let's see what we got. Okay, calcium. Well, if we look at the periodic table, calcium is number 20. Calcium is like 20 with a mass of 40. So that 20 means that it has 20 protons. But it also means that it has 20 electrons. Number of shells, well, if we look here, it is in the first, second, third, fourth row. So it's got to have 4 shells. 1, 2, 3, 4. 4 shells. And how many in the outermost shell, in the valence shell? Well, if we count over, it's 1, 2, second over. So it's got to have 2 in the valence shell. And then neutrons we can just subtract. 40 is the mass. 20 of those are protons. That leaves 20 neutrons. Cool. What about phosphorus? Let's look. Phosphorus is here. 15 and 31. That means it has 15 protons. Must have also 15 electrons, because that's how we get that number. And then we do the mass minus the atomic number. That gives us 16 neutrons, because neutrons and protons are the only heavy things, so they add up to the mass. How many shells? Well, if we look here, phosphorus isn't in the first row, it's not in the second row, it's in the third row, which means that this must have 3 orbitals. And then we can just count over to know how many electrons in that orbital. 1, 2, 3, 4, 5. Silicon, all right, silicon rather, I should say. Same thing, silicon is here, it's 14 and 28. So same thing, we can say, well, if its atomic number is 14, that means 14 protons. But a neutral atom must also have 14 electrons, got to be equal. And then the mass, well, how do you get to a mass of 28 if you have 14 protons? Well, that would be 14 neutrons to bring the mass up to 28, so there we go. And number of shells, I think it's in the third shell, let's check. Yeah, first shell's just hydrogen and helium. Second shell's all these guys, and that's the third shell there. So third shell means 3 orbitals. And then when we want to know how many electrons are in that outermost shell, we just count over. Sodium has 1, magnesium has 2, aluminum 3, so silicon has 4 electrons in its outer shell. All right. Draw a Bohr-Rutherford diagram for any one of the elements from question 5. Well, I definitely want to draw one that just has 3 shells. Silicon's the easiest, so I'm going to say silicon. And we know it has 14 protons and 14 neutrons. And we just go, okay. One shell. 2 shells. 3 shells. And we know the first shell holds 2 electrons. The second shell holds 8, and we go 1, 2, 3, 4, 5, 6, 7, and... oh, that's in the wrong spot. Eight. And then the last one, well, we said the valence shell has 4. So the valence shell would have 1, 2, 3, 4. All right. The other two, well, we've got phosphorus and calcium. And we know a Lewis diagram is just the outer shell. So phosphorus has 3 electrons in its outer shell. 1, 2, oh, sorry, has 5. I was going to say, what? 3, 4, and 5. Good. And then calcium has just 2 electrons in its outer shell. So 1 and 2. There we go. What element has 8 electrons? Well, the same one that has 8 protons, which is atomic number 8, and that's oxygen. Roughly 56 AMU. Well, that's easy. Let's just look. There we go. That would be iron. And 24 neutrons. So there could potentially be a few answers to this. This one will be a pain because we have to find one that is 24 more than the atomic number, its mass. So let's just take a look and see what some of the options are. Let's see. So 24 neutrons, well, 48 would be nice. That would just add up. And oh, look, titanium is 40. Oh, but it's only got 22. So that can't be it. Oh, 21 plus 24 would be 45. So scandium works. That might not be the only one, by the way. So if you found a different one, awesome. I'm not going to look for every possibility, but scandium works because it has a mass of 45 and atomic number of 21. And 45 minus 21 is 24. Awesome. Okay. Not to get too much into this, you can figure this out, you did it in class, but when we run an electric current through this, we get, so there'd be water in these to start with, and we would get gases forming, and there they are. And that, the one we have twice as much of, would be hydrogen, and that would be oxygen. And plus burning splint gives you a pop. And this would reignite a splint that had gone out. Okay. Not to get too much into this, but the fact that there is always twice as much, exactly implied atoms always stuck together. And this is how we also start to get the mass of them, because the hydrogen always weighed the oxygen always weighed 8 times as much as the hydrogen. we could conclude that oxygen atoms must be 16 times heavier than hydrogen, because even though there's twice as much hydrogen, the oxygen is 8 times heavier. Group 1 only have to lose 1 electron. So they really want to lose it. Group 17 only need 1 more. And so they really want it. All right, scandium and nitrogen. Let's take a look. Scandium is here. It's got 3 electrons to lose. Right, it's got 1, 2, 3, 4 shells, but that 4th shell, it's only got 3 electrons. So 1, 2, and 3. And nitrogen has, I should color those really, 1, 2, and 3. And nitrogen has 1, 2, 3, 4, and 5 electrons. And so this one's actually quite easy. These electrons, one's going to go there, one's going to go there, and one's going to go there. And both of these are now stable, so that scandium now has no electrons left, which means it's going to have a positive 3 charge because it lost 3 negative electrons. And nitrogen now has those original 5. And that's also got the 3 it got from scandium. And with 3 extra electrons, its charge will be negative 3. That's ionic. Its formula, well, there's just an Sc and an N. And if you remember the naming, that would be scandium nitride. We changed the ending to IDE, and I think that was bonus. All right, NF3 is a compound used in industry. Well, nitrogen, we already said, has 1, 2, 3, 4, 5 electrons in its outer shell. And then fluorine, and we know we have 3 of them, so obviously a bond is going to happen everywhere we have a spare electron, has 1, 2, 3, 4, 5, 6, 7 electrons. 1, 2, 3, 4, 5, 6, and 7. And 1, 2, 3, 4, 5, 6, and 7. And so by just making 1 bond, that fluorine is now happy. 1 bond, that fluorine is now happy. 1 bond, that fluorine is happy. And now nitrogen's making the 3 bonds it needs. So it's happy. And so we end up with a structure that looks like this. And that's covalent because it's sharing. And this you really don't need to remember, but we use prefixes in this. So this would be nitrogen trifluoride. I don't even think I'll put that on your test, because we really didn't talk much about the naming, and that's okay. There you go. That's the test. So I hope that was of some help. I hope this actually streamed. I'm at my parents' house, and their internet is sort of famously terrible. But either this worked or it didn't. In either case, I'll put the PDF up. Ciao.